Good afternoon. I, Professor Niket Shastri from Sarvajanik College of Engineering and Technology, Surat, welcomes you to this. Welcome you all. In today's session, we are going to see some basic aspects of laser that is covered in your syllabus of first year engineering physics. So, in this, laser is a basic concept of light. So in this session we are going to see through the objectives like history of laser, that is how the laser is invented and how why it is invented, characteristics of the laser, why your laser is different from the ordinary light, basic principles of the laser, how your laser works, and then derivation of the Einstein's coefficient A and B, and then after level of the lasers. So these are the journey of the laser that we are going to begin. First of all, the laser is basically light amplification of by stimulated emission of radiation. So whenever we want to understand the laser, we should understand all the basic of all the fundamental words of this light amplification by stimulated emission of radiation. So what do you mean by the light? The light has a dual nature. According to the de Broglie hypothesis, the light has a dual nature. First, it has a wave nature, and second, it has a particle nature. So light sometimes behave as a wave as well as sometimes it behave as a particle. According to the wave nature, the light is an electromagnetic wave which consists of electric field vector and magnetic field vector, which are vibrating perpendicular to each other and also perpendicular to the direction of the propagation of light. So from the figure you can see that your orange color is your electromagnetic wave, orange is your electric field, and your purple is your magnetic field. They are vibrating perpendicular to each other, and they are also vibrating perpendicular to the direction of the propagation of light. So here your arrow shows your propagation of light. So according to the wave nature, your light is an electromagnetic wave, and which is basically transverse in nature. Some of the phenomena like polarization, interference, diffraction, reflection can be understood by this wave nature. And according to the particle nature, according to the particle theory, the light is a bundle of definite energy which is known as the photons. So basically they are quanta of energy which are known as the photons, and energy of the each photon is given by E is equal to h nu, where h is a Planck constant which has the value 6.625 into 10 raised to minus 34 joule into second, and nu is the frequency. So from this equation we can see that your energy of the individual photon varies with the frequency as well as the wavelength. So as we have a different color light, the photon of the each color has a different energy packets. So some of the phenomena like Compton effect, photoelectric effect, even the laser can be understood with the help of this particle nature of the light. So your light behave as light has a dual nature. One is a particle nature and the second one is your wave nature. Now the question is why your laser is so popular, and why the laser has a you can say why the laser is why the laser has some speciality and it is different from the ordinary light. So we can see in history, in 1917 the Albert Einstein laid the foundation for the invention of the your laser in his paper Quantum Theory of Radiation. So in 1917 Albert Einstein laid the foundation for the invention of the laser in his paper. He studied that stimulated the absorption of the photon by the atom, and in his study, he showed that your external photon is absorbed by the atom and electron make the transition from the ground state to the excited state. Now, according to this, he has another thought in his mind. If there is a possibility your external photon can make the electron from the ground state to the excited state, that is another possibility that your external photon can stimulate that excited electron to the ground state, and that is a next possibility when your electron or the excited photon makes or force the excited electron to come down. So that is a lead or the foundation for the stimulated emission. So according to the Einstein, if the photon or the external photon can take your electron from the ground state to the excited state, it also can make your electron from the excited state to the ground state. So there are equal possibility your photon can absorb and your electron can go from the ground state to the excited state, and there is a same possibility your external photon can make that electron or the excited electron to come from the excited state to the ground state. So that was the hypothetical thought of the Einstein in 1917, and it took around 34 years to convert that thought into the reality. So in 1953, these three gentlemen, Charles Townes, James Gordon and Herbert Ziegler, converted or demonstrated this thought of Einstein by using the microwave. They demonstrated the principle of the stimulated emission by using the microwave, which is known as the maser, which is the microwave amplification by the stimulated emission of radiation. So that's why how and then after 7 years in 1960, they shifted from the microwave frequency to the optical frequency, which is popularly known as the laser, which is the light amplification by the stimulated emission of radiation. So around after 40 years, your thought of the Einstein converted into reality. So the postulate of the Einstein, it is converted into reality by demonstration of the maser, as well as they have shifted from the microwave frequency to the optical frequency, and they in 1960 they demonstrated the laser, that is a light amplification by the stimulated emission of radiation. Now, why this laser is different from the ordinary light? We have the ordinary light source like you have tube lights, then incandescent bulb, CFL bulb, and so on. So what is the special in the laser? So there are some special characteristics of the laser, and that's why the laser is more popular apart from your ordinary light like your bulb as well as your tube lights. The first characteristic is your laser is a highly monochromatic light. Second is it is highly coherent light, highly directional, and highly intense. So these are the four characteristics of the laser, through which or due to this your laser is very prominent or very popular apart from your ordinary light. The first characteristic is the monochromaticity or the monochromatic light. The laser is a monochromatic light, that is, the laser has a mono or the single wavelength. So whenever there is an emission of the laser, it emits only a single color or the single wavelength, and it has a definite wavelength. Your sun has 7 colors, your white light has 7 colors, that has 7 different wavelengths. But this laser, whenever you have a laser, it will have only single wavelength, that is only single color, and that's why your laser is a highly monochromatic light, or it has a single color only. And this characteristic comes because your laser is emitted or laser is created from the transition of the electron from the definite energy levels. Whenever your electron make the transition from the one particular energy level to the next, your laser or the emission is emitted. So that for laser action occurs between the two particular energy levels only, and that's why your whatever the emission of the wavelength is a specific wavelength. So that's why your laser has a specific wavelength only. It doesn't have any other wavelengths. So that's why your laser is a highly monochromatic light. That is, it has only single color or the one color only. Then second is a coherence. Laser is a highly coherent light. The coherent light are the light waves that are in phase with one another. So basically, the coherent light is the light which are having the same pattern. If your light wave moves in the same pattern or the same similar pattern, then such waves are known as the coherent. If there has a haphazard or the random methods or the random patterns, such light is known as the incoherent. Your bulb or the tube lights are the incoherent light because in that the wave pattern are indefinite. So this pattern has a incoherent beam. So in this you can see that the pattern of the individual waves are they don't have any specific pattern. So they are not in the same phase. But if you see this, they are the coherent. So if you can see the individual beams, they are moving in the same pattern or all the waves are in the same phase. So if the waves are in the same phase or they pretend the phase difference between the two waves remains constant, such waves are known as the coherent wave. Coherent are, in the simple language you can understand that coherent beams are the similar beams. So you can see in all the patterns all the waves are in the same pattern or they are similar. So such waves are known as the similar or the coherent beams. So laser is a highly coherent beam because all the photons of the laser are emitted by stimulated emission, and that particular stimulated emission are done between the two definite energy levels. So that's why all the patterns or all the waves are in the same phase. This you can see that in the first figure you have a sunlight which has 7 different colors and indefinite patterns. Second is a LED or your general tube lights. In also they have different patterns. They don't have any similarities. So that is an incoherent wave. And the last one is your laser, in which you can see that all the 3 beams are varying in the same fashion. So if you measure the phase difference or if you measure anything at any particular point, you will have a same or they remain constant. So the phase difference between the individual waves remains constant, and that's why they are known as a coherent beam. So you can see that in the last pattern your laser has a very coherent or they are in the same phase. That's why your laser is a coherent beam. Now the third one is the directionality. The laser beam is a highly directional, which implies the laser has a very small divergence. Right? In the figure you can say that the laser beam has a very sharp line. Right? But if you have any ordinary light, they have a divergence. So from a origin or from the source of the your bulb, and if you have a screen, so as your light moves from the source to the screen, your divergence increases. Right? So that is your divergence or your ordinary light. But for the laser, your divergence is negligible. So your laser is a highly directional. So for the laser, your divergence is absolutely 0. The fourth one is the intensity. Laser is a highly intense beam. The intensity of the light source is the power emitted per unit surface area of the solid angle. Right? So basically, if the divergence of the laser is very small, then the area of the beam is very small. So your intensity is given by power divided by the area. So if your area is very small, then automatically your intensity will be very high. So it is a power emitted. The intensity is the power emitted per unit area of the solid angle. So that is the power emitted, that the power which is emitted from that solid angle is shown in the figure. The arrow which is come out from that solid angle, it is a power. So it is a power divided by the your area gives the intensity. So if that area is very small, then your intensity will automatically increase. Right. So that is your fourth characteristics of the laser. Okay, your laser is a highly intense beam, and that's why it is dangerous to see in the laser. So if you can't see the laser with your eyes, right? If your laser goes into your eyes, it has a very high intensity, so it can burn your eye cells also. So these are the four characteristics of the laser. First is the monochromatic light. The laser is a monochromatic light. The laser is a coherent light. The laser is a very directional light, and the fourth one is a laser is a highly intense light. Right. So laser has a single wavelength. Laser is a coherent light. Laser has a very directional. They are the directional. Then the laser has a highly intense beam. So the intensity is given by this equation. That is already we have seen this. Now there are 7 basic components of the laser. So if you want to understand the working of the any XYZ laser, you should understand all the 7 components of the laser. That is, the first one is as there are 7 notes in the any music. So these are the 7 notes of the laser. So if you understand this, all the 7 components, you can easily understand the working of any XYZ laser. The first one is a spontaneous emission. Second one is a stimulated emission. Third one is a amplification. Fourth one is a population inversion. Fifth one is a active medium. Sixth one is a pumping, and the seventh one is a optical resonators. So these are the 7 basics of laser, and by which you can understand the any construction and working of any XYZ laser. Now we are going to see the first component, that is a spontaneous emission. Now whenever your external photon is interact with the